Now children, let us see some important topics in real numbers. So to understand the topics, we have to understand division algorithm, and the next solving some problems using this division algorithm. So to get the concept, you see these four situations. So I am reading those situations. So first situation is a pack contains 4 ball pens. Ravi bought 5 such packets and 1 pen separately. What is the total number of pens he bought? And the second situation is a pack contains 3 erasers. Lata bought 4 such packs and 2 erasers separately. So what is the total number of erasers she bought? Okay, now the third situation, a pack contains 15 pencils. Rahim bought 3 such packs and no pencils separately. So what is the total number of pencils he bought? Okay, now fourth situation, a pack contains 12 sharpeners. Mary bought no packs but 5 sharpeners separately. So what is the total number of sharpeners she bought? Okay, so understand each and every situation, that means every question, then we have to find the totals from each situation. So here we have a table. So in that first column, item, that means the ball pens, erasers, pencils, sharpeners. Okay, in the second column we have the pieces per pack. Okay, and the second column number of packs, and third extra items, and the last column is total. Okay, so now here in that first question or first situation we have ball pens. So pieces of 4 ball pens, that means that pieces per pack is how many are there? 4. So number of such packets are 5. Extra items are only 1. So totally how can you say? 21. Simply you can multiply 4 into 5 plus 1. Already we did this type of sums in lower classes, but to get the concept on division algorithm, you have to understand this concept clearly. Okay children, so now erasers. So pieces per pack is 3, number of packs 4, and extra items are 2. So here also we can get easily by multiplying 3 and 4. 3 4s are 12, and by that extra items, that is simply extra sharpeners 2, then we get 12 plus 2 14. So like that we can get pencils. Each pack contains 15 pencils. We have such packets 3, and no extra pencils are there, so extra items are not there, so we can easily get 15 3s are 45. Now sharpeners. So they in that sharpeners 12, but there are no packs, so she bought only 5 sharpeners, so that's why 12 into 0 plus 5. Here no packets means you have to consider it as 0. So 12 into 0 plus 5, we get ultimately 5 sharpeners. Okay, so these tables, by using this concept or this table, you can write easily the division algorithm. First time we are writing in numerical form, that is total pens are 21. Okay, ball pens are 21. So that 21 can be written as 4 into 5 plus 1. By that first situation, we have 4 pencils in each pack. So that number of packs are 5. So 4 into 5 plus 1. Okay, in the same way, total erasers 14. So 3 into 4 plus 2. Each packets containing 3 erasers, and such packets are 4, and separate items are 2 sharpeners. So totally we get 3 into 4 plus 2, 3 into 4 12, 12 plus 2 14. So like that we can understand the division algorithm. That means already we learned in lower class, that is dividend is equal to divisor into quotient plus remainder. So 45 and 5 also you can write easily. Okay, so your divisor, dividend, quotient and remainder. Okay children, so in this class we have to suppose whenever A divided by B, then we can get Q and R are the quotient and remainders. So by applying that above equation, we can write simply A is equal to BQ plus R. So from the above we can understand that A is equal to BQ plus R, where 0 less than or equal to R less than B. So children, see this R value is very important. These values are runs from 0 and less than that of the B. So R value including 0 and that value R must be less than the B. So which is known as the division algorithm. Okay. So to get the clear cut information, you have to read once again that 1 and 2 pages of chapter 1 of the textbook for understanding that division. Okay. Now to get a clear understanding, we have here one more explanation. All the whole numbers when made into two groups, so we get them like by means of divisor 0, we got the two groups. First group is here 0, 2, 4, 6, 8, 10, 12, 14, 16 up to so on. The another group is 1, 3, 5, 7, 9, 11, 13, 15, 17 up to so on. So you can identify easily the what type of numbers are these. So first group is here even numbers and second group is here odd numbers, as you know all these. But again here by applying the above equation to get the perfection to write the above equation in the form of A is equal to BQ plus R. Okay, so just practice these equations here like this. Here I am taking 0 divisor 2, simply 2 into 0 plus 0. Why? Because 0, to get 0 we have to write simply 2 zeros are 0 only, no? So that's why 0 is equal to 2 into 0 plus 0. Here 0 is taken as A, 2 is B, and other 0 is Q, and the last 0 is R. So just you have to keep in the mind, dividend is equal to divisor into quotient plus remainder, or simply A is equal to B into Q plus R. Okay children, by the same way the 2 also written as 2 is equal to 2 into 1 plus 0. That means here whenever divided by 2 by 2, we can write 2 is equal to 2 into 1 plus 0. Here again 2 is taken as A and 2 is other 2 is B and 1 is quotient Q and 0 is the remainder R. So like this you can write 4 is equal to 2 2s are 4, that's why 2 into 2 plus 0. And 6, 2 into 3 plus 0, and 8, 2 into 4 plus 0. So by seeing these division equation, you can easily understand how to write these equations in the form of A is equal to B into Q plus R, where R is must be less than B and it is starting from 0. Okay, just observe this carefully. And next in the odd numbers, that is if you take the 1, if it is divided by 2, we get simply 2 into 0 plus 1. In the same way 3, if it is divided by 2, we get remainder 1, that is 2 1s are 2 plus 1. Okay, so and 5 is equal to 2 into 2 plus 1, and 7 2 into 3 plus 1, and 9 2 into 4 plus 1. So like this you can easily understand. So and so on. By seeing the above equations, we will get one pattern. So what's the pattern? So we can observe that in the first group they are of the form 2q plus 0. Okay, so here in the all numbers we are taking 2 is the divisor, no, that's why 2 into q plus 0 is the for the even number part, that is first group part, and in the second group they are in the form of 2q plus 1. You can easily write general forms like that. Okay, so for divisor 2 forms of A, generally here A is any integer, general form is taken in, that is in integer place you can write A. So A is of the form R 2q plus 0 2q plus 1. A is in the form 2q plus 0 or 2q plus 1. In this 2q plus 0 are even numbers, 2q plus 1 are the odd numbers. So by this way you can write easily that forms in by means of division algorithm. Okay, so here we have a small table to understand the clear the division algorithm. So here divisor is taken as 2, 3, 4, 5. So whenever you take divisor 2, obviously you get the remainders what? 0 and 1. Just now we saw, no? So possible forms of A are A is equal to 2q plus 0, A is equal to 2q plus 1. Clear? So that means here we are writing an integer whenever it is divisible by 2 in the form of bq plus r, that is A is equal to bq plus r. We can write A is equal to 2q plus 0 and A is equal to 2q plus 1. Okay, whenever it is divisible by 3, what are the remainders? 0, 1, 2. So A is equal to 3q plus 0, A is equal to 3q plus 1 and A is equal to 3q plus 2. Okay, so generally if you take 3, for example I am taking 3, if it is divisible by 3, okay, what is the remainder? 0. So and next I am taking next immediate number 4. After 3, what we get? 4. So if it is divisible by 3, what you get remainder? 1. That is 3 1 the 3 plus 1. So we get 3q plus 1 form there. Okay, and next I am taking 5. So if it is divisible by 3, we can get 3 into 1 plus 2. Okay, not only 3 4 5, you can take the from starting one also. Okay, that means 1 2 3 also you can get. So by that way also, by taking those numbers also, you may write in the form of 3q plus 0, 3q plus 1, 3q plus 2. How? 1 is divisible by, if it is divided by 3, we get simply what? 3 zeros are 0. So here quotient is 0. So that's why 1 is equal to, we can write 3 into 0 plus 1. Okay, so it is in the form of 3q plus 1. So whatever you take the number, if it is divisible by 3, you must get the forms of 3q plus 0, 3q plus 1 and 3q plus 2. So that means by seeing the divisor, you can easily say the number of remainders. Okay, so and the remainders, you can easily say the remainders. So if the integer is divisible by 4, what are the remainders? 0, 1, 2, 3. So if you take a general 4 consecutive numbers, by divide them by 4, you can get easily the 0, 1, 2, 3 as remainders. Okay, so by that way you can write in the general forms. Whenever an integer divisible by 4, you may get A is equal to 4q plus 0, and if it is and another number divisible by 4, then we can get 4q plus 1, or if it is divisible by another number divisible by 4, then we can get A is equal to 4q plus 2 and A is equal to 4q plus 3. So these are the general forms whenever any number is divisible by the 4. So again 5 also. So you will get easily the remainders 0, 1, 2, 3, 4. Okay, so children, by understanding this, just open your textbook and see the examples whatever they are given. So I will scroll these examples one by one, you can understand easily. Okay, once you see this, 1 2 3 examples, very easy, no? You can easily note down and practice them. Now children, see this first example. Find the values of Q and R if A is equal to 88 and B is equal to 17. Simple division it is. Here B is taken as generally divisor and A is a dividend, that is 88. So divide it by 17, that is if 88 is divisible by 17, we can get 17 5s are 85, then the remainder is 3. So by division algorithm we can write 88 is equal to 17 into 5 plus 3. That is when we compare with this by A is equal to B into Q plus R, then here B is equal to 17, A is equal to 88 already given, so here simply Q is 5 and R is equal to 3. So find the values of Q and R if A is equal to 3 and B is equal to 7. So you can start with 0 also. Whenever B is 7 and that A value is 3, that means it is simply it is not divisible actually, but we have to know how to write in the form of A is equal to BQ plus R. Here whenever 3 is divisible by 7, you just write 7 zeros are 0. That means 3 is not going by 7 table, but with that 0 only you can write 7 zeros are 0, remainder 3. So that's why here 3 is equal to 7 into 0 plus 3. So by that way we can write Q is equal to 0, R is equal to 3. It's the only purpose, it is only the purpose of understanding the A is equal to BQ plus R statement. Okay, that is division algorithm statement. Okay, and now very important, now see this third example. Show that even numbers are of the form 6m or 6m plus 2 or 6m plus 4 where m is a whole number. See children, here already they given a general form 6m or 6m plus 2 or 6m plus r, just like bq plus r. So here in place of b we have already 6, in place of q we have m, in place of r we have 0, 2 and 4. So simply you can easily understand here the divisor is 6 by saying that 6m, 6m plus 2, 6m plus 4. You can easily understand the given divisor is 6. So by saying the divisor 6, can you write the reminders? Yes, we can easily write the reminders 0, 1, 2, 3, 4, 5. Okay, see the children, the conditions are satisfied by saying the division algorithm statement. There we have the r is in between 0 and b, that is including 0 and b, less than b. That means here the r values are starting from 0 and ending with 5. Okay, if it is 4, if the b value is 4, what are the r values? Simply you can say 0, 1, 2, 3. So are you followed? So again, if it is 5, then if the b value is 5, then r values are what? 0, 1, 2, 3, 4. Already we did this practice in before table only. Okay, you just keep on practice to understand these type of sums. Very easy. You just take a pen and paper, just practice all these simple equations. You will get a perfection to write this type of the Euclid division algorithm type of equations. Are you followed? So now here forms of A, actually according to problem we have the forms of A is any integer. You can assume any integer by A. Okay, generally in this textbook there are each and every sum they are taking the integer, general integer is A. Now here are of the forms what? 6m plus 0, 6m plus 2, 6m plus 3, 6m plus 4, 6m plus 5. How we write all these forms by using that division algorithm. What is that? A is equal to bq plus r. Here a value is generally always taken as a and b value is here 6, but here that in place of q we have here m, that's why they are writing m, and r value here changed value is only simply r values, that is a is equal to bq plus r, that is a is equal to 6m plus for the first value 0 we can write 6m plus 0, for the next value 1 we can write 6m plus 1, and the next 2 we can write 6m plus 2, and the next 6m plus 3, next 6m plus 4, and the last 6m plus 5. Simply remove that r values by that respect to 0, 1, 2, 3, 4, 5. Okay, now but we know that even numbers are exactly divisible by 2. Why? We have to prove that the even numbers only. Show that even numbers, they are asking even numbers. So observe that 6m. So that 6m can be written as 2 into 3m. Okay, so that's why it is exact divisible by 2. That's why it is a what even number form. Already we learned in the previous also what are the even numbers, what the particular forms 2q. Okay, here we have simply 6m is 2 into 3 into 2 into something we got. That's why it is simple, it is a even number. And 6m plus 2 also, from both of these we can take common 2. Why? Here 6m nothing but 2 into 3m plus 2 nothing but 2 into 1. By taking 2 common, we can write 2 times of 3m plus 1. And 6m plus 4 also, take 2 from these two, we can write 2 into 3m plus 2. So even numbers are of the form 6m or 6m plus 2 or 6m plus 4, particularly for this sum. So whenever the divisor is 6, then the even number is of the form 6m, 6m plus 2 or 6m plus 4. Okay, simple sums like that only you have to do. And the next we have the next sum. See this here, very important for 4 marks in annual examination. So show that the square of any positive integer is of the form 5m or 5m plus 1 or 5m plus 4, where m is the whole number. So here b is equal to 5. Obviously we can say b is equal to 5. Then what are the remainders? Simply you can write 0, 1, 2, 3, 4. So what is the general form here? A is equal to 5q plus r. Okay, you can easily seeing that divisor, that is b value, you can easily write this form. A is equal to 5q plus r. So by seeing the sum, you just identify the what is the b value. To identify the b value, you just observe that 5m, 5 plus 5m plus 1 and 5m plus 4, all these are already in the form of bq plus r. That is, here 5m nothing but it may be in the form of 5q plus 0, and 5m plus 1 is 5q plus 1, and 5m plus 4 is 5q plus 4. So by that way, here by saying the sum only, we can write, we can easily write that forms. Okay, now squaring on both sides, we get a square, a is equal to 5q plus r. By squaring on both sides, we get 5q plus r whole square. Then by applying a plus b whole square formula, we can write it as 5q whole square plus 2 into 5q into r plus r square. What is the formula? A plus b whole square formula, a square plus 2ab plus b square. So by applying that, we can write simply 5q whole square plus 2 into 5q into r plus r square. So 25q square plus 10qr plus r square. So take 5 from both of these first two terms. So 5 into 5q square plus 2qr plus r square. So the general form is here simply a square is equal to 5k plus r square, where k is equal to 5q square plus 2qr. Now again, to simplify the sum, we are writing again a small table. Here r values are 0, 1, 2, 3. So this table is simply you have to write this table for the place. Okay, if you write individually one by one, it will take a large space. So that's why if you write in a table form, it is looking like a simplified one and looking beautiful. Okay, so write these steps in the tabular form. So r value a square is equal to 5k plus r square, and the final form. So the result what we need. So here first of all, for r is equal to 0, so substitute r is equal to 0 in this 5k square plus r square. Then we can get 5k plus 0 square, that is 5k. Final form is 5m and 1, and 5k plus 1 square. Simply we can write 5k plus 1. Simply we have to write 5m plus 1. And again 5k plus 2 square, you can write 5k plus 4. Simply you can write it as 5m plus 4. And if r is equal to 3, we can write 5k plus 3 square. See this, children, carefully. 5k plus 9. So 3 square nothing but 9. So here 9 can be written as 5 plus 4. That's why 5k plus 5 plus 4. Take 5 from both of the first terms, so we can get 5 times of k plus 1 plus 4. In k plus 1, you can write some multiple m, 5m plus 4. So here k plus 1, whatever it may be, 5 into something we got. So that's why 5m plus 4. M is here some multiple or some integer. So k plus 1 is considered as here m. Okay. So now here the last one, 5k plus 4 square. Here 5k plus 16. 5k plus 16 can be written as 15 plus 1. So take 5 from both of them. So 5 times of k plus 3 plus 1. Here also you can consider 5k plus 3 as m. So 5 into something, m is something value. So 5m plus 1. So like this we can easily understand this important sum. Do it 2 to 3 times. Why? Because to get the clear concept, you may get 4 marks in the annual examination. So be perfect. We practice well. Okay, now in the same way we have the other important sum. Show that the cube of any positive integer is the form 9m or 9m plus 1 or 9m plus 8, where m is a whole number. So see children, here also we have the 9 multiple. So in divisibility rules, 9 and 3 are the same divisibility rule. So that rule is here applied. See this properly. Solution, here b is equal to 9, but it is multiple of 3. So we can take the b value is 3. Why? Because 9 and 3 are having the same divisibility rules. Okay. What is the divisibility rule of 3? If the sum of the digits the given number is a multiple of 3, we can say it is divisible by 3. In the same way we can say the for 9 also. Are you followed? So now here I am taking simply b is equal to 3. Then whenever b is equal to 3, so our values are what? 0, 1, 2. Okay, so now a is equal to, we can write it as 3q plus r. Now they are asking what? Cubing, cube of any integer. So cubing on both sides, a cube is equal to 3q plus r whole cube. That is it in the form of a plus b whole cube. What is the a plus b whole cube formula? A cube plus 3ab plus 3ab into a plus b plus b cube. Otherwise we can write that lengthy formula also, but here they are taking 3ab into a plus b. Okay, so 3 in a place we have to write 3q and b plus r. So 27q cube plus 3 into 3q into r into 3q plus r cube. Okay, so from first two terms I can take common 9 times of 3q cube plus qr into 3q plus r cube. So 9m plus r cube, that is 3q cube plus qr into 3q plus r generally taken as some k value or m value. So now again here we need to get the other forms. So that's why r value is here 0, 1, 2, and that a cube is equal to 9m plus r cube. Then we have to get the final forms. So whenever r is equal to 0, we can write 9k plus 0 cube, that is 9k, that is in the final form 9m. And if r is equal to 1, that is 9k plus 1 cube is equal to 9k plus 1, the final form is 9m plus 1. And r is equal to 2, then 9k plus 2 cube, 9k plus 8, so that is 9m plus 8. So the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8, where m is a whole number. So like this you can do these type of sums, practice well. So here again we have the worksheet. Do all these worksheets, very important. Okay, government is giving this type of worksheets very neatly. You have to follow these worksheets till before here you have to note down in a classwork, but worksheet you have to submit in the WhatsApp groups. So that's why worksheets are here given. So here see the worksheets one by one. I am scrolling slowly. Okay, or otherwise you can pause the video and you can write neatly the questions. Okay, so this is the feedback on last one. Okay.